Hello, my name is Miguel Ángel Contreras Flota, and this is my work Physico-mechanical characterization of a green concrete made from glass waste as a partial substitute for stone aggregates. During the last century, increased industrialization and urbanization have led to massive use of concrete. Therefore, the consumption of natural aggregates for hydraulic concrete mixes has also increased, since they represent approximately 60 to 75% of the total volume of the mix. The exploitation of natural aggregate banks has serious environmental consequences, mainly the modification of natural drainage, the partial or total elimination of the flora characteristics of the site, and even greenhouse gas emissions. This research proposed the analysis of a new concrete by means of experimental laboratory tests in order to obtain its characteristic. This new concrete will be made by substituting waste glass as partial substitute for fine and coarse aggregates, and will be analyzed by replacing different percentage of aggregate with clays. The materials used for the preparation of concrete are sand from the Joyitas Bank, gravel from the La Roca Bank, waste glass, and Portland cement. 11 concrete mixture we prepared the control A10, A20, and A30%, G10, G20, G30%, and combination of A and G, 10%, 50%, 10 and 20%, and 20 and 10%. Where those of nomenclature A are those of substitution of thin aggregate by ground glass, those of G are those of substitution of coarse aggregate by crushed glass, and those of A and G are those of substitution of both stone aggregate. The non-destructive test performed were ultrasonic pulse velocity and electrical resistivity, both were performed at 28 and 60 days. The only destructive test performed on the specimen was the compressive strength test at 28 and 60 days. The results for the ultrasonic pulse velocity test indicate that all the mixtures present results greater than 40,000 meters per second presented at the level quality. For the electrical resistivity test, all the mixtures are below the minimum specified limit, resulting in excessive interconnected porosity. And for the compressive strength test, we can observe that the only ones do not meet the designed strength of the 25 megapascals are the A30% and G30% mixes. As conclusions, we can say that the 11 mixtures complete with the specification of the ultrasonic pulse velocity presenting a durable quality. For the electrical resistivity, all the mixtures present excessive interconnected porosity, and for the compressive strength, the only ones that do not complete with the design strengths were the A30% and G30% mixes. From the above, it can be concluded that it's feasible to partially replace stone aggregates with glass waste, probably up to 25%, since it meets the requirements of the standards and would also reduce the environmental impact generated by giving second life to glass waste and reducing the overexploitation of stone materials.